And welcome back. Now today I'm going to talk about this little board here. Although you might be able to read something that says Leonardo down here, it's not a Leonardo. You can probably see it says there Pro Micro. Now if you look on the list of Arduino boards, Arduino don't make a Pro Micro, they do make a Micro, but they don't make a Pro Micro. So what's this? Well, this is a clone of Sparkfun's implementation of the Micro, which they call a Sparkfun Pro Micro. This is a clone of that. And the difference is that the chip on here, rather than being an ATmega 328P, which we've all come to know and love, this has actually got a ATmega 32U4 chip on it, which is sort of the same-ish, in that you can still write C++ code for it and it all compiles great. But the USB implementation is actually on chip. We don't have a separate chip for the USB implementation. Now that's a sort of disadvantage in one way, because it means when you plug in your USB cable and this board is then reset, your Windows and Mac will see a different USB port to when it's running. So you have two different ports, but they only appear at separate times. So it can be a little bit finicky sometimes to get this thing to upload. It basically, I've found in my experience, it either just works as a normal Uno does and you don't really notice the difference, or it's a real pain in the what's-it to get this to work. And in my workshop I've got a Windows 7 PC and that seems to work a lot better, especially with this particular board. The actual project that I've now completed uses an identical board to this, at least I thought it was identical, but it doesn't have any problems at all with my Windows 10 machine. Now, why do I want to use one of these? Why don't I just use a Nano or something? Well, the reason is, this device, when you connect it up with the USB and it's running, can send commands back to your Windows as though it were a keyboard. So it emulates a human interface device and is enumerated as a keyboard. Now, there is a keyboard library that only works with Arduino Leonardos and Sparkfun Pro Micros, and I presume Arduino Micros. And you can tell Windows, I'm sending you back down this USB cable the equivalent of, I don't know, K or Z, or better still, Control-Shift-Delete or Windows key L to lock your machine. So this does really act like a keyboard. Why do I want that? Well, when I'm making these videos, and you can see me in that bit there, that's me, that's a different camera to this camera here. Of course, this is my main HD camera. But for me to switch things on and off, so for example, there's me gone, and there's me back again, what I would normally have to do is take my mouse and click something on screen. Now that's not onerous in itself, but when you're trying to demo a project, the fact you've then got to take your hand away, see, move the mouse, this one here, find the actual place on the screen, and it's a tiny little icon on the screen, like I've got to click it, and there it is off. How much easier would it be if I could just press a button? So my original thought was, great, we'll use the analog ports on here as sort of touch switches, so I can touch them. That will then be detected by the board. The board will then say, you've touched analog pin 1, I'll send down the equivalent of hotkey, whatever, Control L or something, which would be that. Now as you can see, I'm moving my hand this way because over here I have indeed implemented as a sort of prototype the entire project, which allows me to switch windows and turn various bits on. So if I press this one here, he said, there we are, that's me, switched on. If I press this one here, off it goes. So this is acting as a keyboard, sending out commands which my video software interprets as sort of a global hotkey and detects what it is I'm doing. So that was the idea behind it. Now, using the analog pins on here probably was never going to be the best possible solution. So I looked around to see what else I could use. Now, Adafruit make a breakout board for the Cap1188 touch switch, which is made by Microchip. Quite ironic, because I started my life off in Microchip microprocessors for many years before I switched to Arduino. So we're going to use a Cap1188, and when I first started the idea of this project, I made the intro to the project 2 or 3 weeks ago now, but of course it's moved on since then. So I started off wanting to do this, then I introduced the Cap1188, which you would have seen as part of my video selection. It is video number 28, which introduces the Cap1188 touch sensor breakout board, and which is what I used. And indeed, they're not that cheap. I paid about, was it about £7, about $10-ish? Whereas in the States, you can buy all sorts of touch sensitive boards from Sparkfun for about $7. So it's cheaper in the States. But anyway, that notwithstanding, I realised that there was a better solution than trying to use the analog ports on here. So what I'm going to try and do is drop in a bit of that video now. And if you want the full details, go to video number 28, and then we'll see how it turned from this to the finished product. This, well, I say finished product, that's a prototype. I don't really consider bolts with washers through them as sort of a very good final implementation, but it certainly works. And I'm looking around now, of course, to smarten this up. However, given it's only me looking at this, well, you too now, I suppose. You know, this is functional and it works, but I want to smarten that up. But that's just, I don't know, it's just aesthetics, isn't it, really? So let's discover a bit more about electronics and come back to the actual project. Right, back to the workshop. First of all, it's this thing over here. In fact, it's this one here, which I don't want to go too close to because you'll see why. If, in fact, I press this green wire here, hello, here I am. Yes, you might have guessed it. This is a touch control unit, and it's actually a Cap1188 breakout board by Sparkfun. What are we going to be using it for, in conjunction with this Leonardo style micro, is to have this to control my videos. So if I press other, well, what will be buttons on here, not button touch pads, you'll see if I press this second one, we should go to our code window. There we are. And if I press my third one, which is this black one down here, that's the same code window but with me in it as well. And finally, if I take, let me think, if I take myself off that picture, if I press this green one, I should come back. There we are. So I think you get the idea of what's happening on here. So let's go back to the main window. Right. So this touch control unit is going to be built into a little box with some touch pads for the 3 main views that I use, and then the webcam, that's me, and the picture-in-picture of my workbench. So if we would go to number 2, for example, this workbench picture here is embedded into this big main picture, which I can't actually touch, of course. So I'm constrained within here to this, and this will be controlled via the touch switch too. So here's the project general layout. I've got the 2 boards. That's the Arduino, that's the Cap1188. Bit of VeroStrip. Actually, it's not VeroStrip, it's a clone of VeroStrip, whatever it is, strip board. An 8-pin header here, even though I'm only going to use 7 wires, but I haven't got a 7-wire one, so 8-pin I'll have to do. And funnily enough, there are 8 touch pins on there, so if in the future I ever do need another one, it will be ready for use. Now the front panel touch pads, if you like, I'm going to go cheap and cheerful on this. After all, it's only me using it. I'm going to use these washers with a bolt like this put through, and on the underneath there'll be some little solder tags like these, so I can solder the wires directly onto them, all 7 of them, and wire them straight into header pins here. So I'll probably sacrifice a few non-DuPont cables that I mentioned in one of my other videos that I don't particularly like, the single wires. Well, now here's a chance for me to use them. Or for neatness, I might well use an 8-way DuPont cable just to, I don't know, just make it look nicer. Now, of course, if this were a commercial product, there'd be several changes. For a start, this board is ridiculously large for what's on there. I mean, this would be really crammed up. There wouldn't be all these pins soldered on there, it would be just the ones we absolutely need. ditto for this one. So these would be really, really close. Obviously it wouldn't be strip board either, it would be printed circuit board. And I guess this front panel, well, certainly wouldn't have washers on like this. It'd have a, I don't know, custom made touch panel, I suppose, in some way. I mean, what these manufacturers can do, it's absolutely amazing. But as I say, this is only for me, so, well, actually, I say it's only for me. It's not really, is it? It's for you, dear viewer. The person watching this video at this very minute is getting the benefit of this, because as I touch these and flip to different camera angles and views and whatever, it's you that gets the benefit, ultimately. But, yes, it is for me while I'm making that video. Now, one little tip I should have mentioned a while ago is that when you're using strip board like this, I have found that these strips do oxidize over, you know, time, over several months, and I've had these ones for, well, several months. So what I do is clean them up using a bit of non-wire wool. So it looks like this. It's just a sort of a scouring pad, really, I suppose. I think it's used in decorating. I'm pretty sure I cut this up from some decorating material. So it's like wire wool, but it's not. It's nylon, but it's quite rough, and it's great for going over these strips. It gets them nice and shiny, as you can probably make out from here. They're good shiny, and best of all, of course, it doesn't leave little tiny strands of wire on here, or even filings that you just might not even see, and it causes havoc with your program. So a nylon one, totally insulating, and does the job just as well. It's a bit more gentle, really, on the board. Right, that's where we are at the moment. More when I get the thing a bit further along. So here's the board, the VariStrip clone with the header pins already soldered in, and that's the underneath with all the tracks broken in the right place. So this is the first time I've actually hooked it up. As you can see, I've put a few links on the board. I didn't realise there was so few, actually. So on this screen now, if I'll film the screen, you can see that the debugging window there is outputting the pins that I've touched. There's the code. That may change by the time you see this again. But if I now touch a couple of the pins, if I hold this up, you should see, if I touch something over here, there, look, C3, oh, touch the pin 1, C7 or something, 4, 5, 2, 4, 7. So there we are. I mean, it's basically, you can see the lights coming on the Cap1188 anyway. So I mean, that's all sort of, well, working, I guess. Well, I don't mean to sound surprised. It just seemed to be a lot less wiring than I thought. I thought I'd be here for a day wiring it up, but obviously not. Now the next step is to wire up this header socket, which is going to contain the wires to the touch pins. So I probably will use DuPont cables. I'll sacrifice a few because it just seems so much easier, doesn't it? Which means this unit can then go in the bottom of this, nice and neat, and the lid, which will contain the touch pads on the top, can have the cables coming out into the socket here, and you can unplug these then en masse and make it very detachable. So maybe, maybe not. We'll see. Well, the next time you see anything on this video, you'll have found out. Okay, let's get on. So here's the front panel being marked out for the touch pads, pilot holes drilled, little 2mm or something like that, and then enlarged to take 4BA bolts. It's about 1/4 of an inch, I guess. There's the holder pads on the back, all screwed up nice and tight, and the front panel is effectively done. And now just the wiring. The wiring took a bit of time because I've got a heat shrink over each end. As you can see there, keeps it nice and protected. And yeah, looks quite nice when it's all screwed together. And out the back comes the USB cable, and that's pretty much it, really. So let's have a quick run through the code very quickly, and as you can see, Benny, my cat, has decided to join us for this. Hey Benny, you like a bit of C++, don't you? So, now, the code isn't particularly exciting because Adafruit do supply this Cap1188 library, so I mean that takes care of all the touching of the individual pins and all that. And the keyboard library, this one here, virtual USB port sending back data. I've defined here some of my keys that I want, a string substitution value so that I can see what I sent. So my workbench, my code window, the browser, the pip cameras, all that is specific to my project, but it will show you a little bit later how this works. So basically we set up the Adafruit Cap1188 touch object, and well, really there's not a lot to it. Basically it says we start it off, make sure we can find the Cap1188, sorry. Start the keyboard up. If you try using this keyboard, by the way, with a non virtual USB board, so if you tried it with a Uno, you'll actually get compilation errors. Even though you've got the include statement at the top and everything, it won't compile. It's only for boards that have this virtual USB device. So basically what it's saying is here, have I detected a touch on the screen, on one of the pads? Now, I've set this up to say I don't want multiple touches, so if I touch two together, that's not on, because it's never going to happen, is it? And what else? The sensitivity I brought right down, so I've actually got to touch one of these to make it move. So if I actually just touched it, and again, because before as I was bringing my finger towards it, you can have the sensitivity so high, because the higher the sensitivity, the less stability you've got as well. So I've brought that down. So again, has it detected a touch? If it has, and we've had at least one cycle in this loop where we haven't had a key press, that means if I've touched something and I've held my finger on too long, I don't want it to register in the next loop. Oh, there's another key press. The logic is, having pressed a key once and we've dealt with it, it's not going to do anything else until you take your finger off and it says, there's been at least one cycle in this loop to say no key's been pressed. And then here I just say, well, which key was pressed? 1, 2, 3, 4, 5, all the way up to 7, because I don't use number 8, not at the moment anyway. And send out the correct keyboard codes, really. They're all Control-Alt something, so that they're not already assigned in any Windows program. And, well, that's it. That's all it does. I've got my little serial to print here. So if we look at this, this debugging window here, or serial monitor, as I press things, so for example, if I press this one here, which will turn me off, you should see this 5 change, another line appear. There we are, number 1. And if I press it again, number 5. So 5 is on, 1 is off. Ditto for this window itself that you're looking at with my finger in it. If I press that, it's number 2. If I take that, so 4 is off. So 2's on, 4's off. And that's all there is to it, really. I mean, you can experiment with a couple of the examples that they give you in their keyboard, as long as you've got one of these micros, and it's easy peasy. That's all I can say, really. I'll put this out in the bottom, of course, and you can play about. So you could say that's the end of the project, really. I mean, we've now got the finished unit. I'm not particularly overawed with this sort of effect with washers and bolts and whatnot. I just did it to to prototype it, really. I made these 3 large washers because they're the 3 views I've got, and these 2 are sort of picture-in-picture camera units here. But I think I can probably do better. Also, to be quite honest, I don't like this box particularly because it's flat. Really, you want something that stands at an angle, but like an instrument case. That'd be nice. You can have some of these touch pads then on the front rather than on the top, which is why I've got it on this sort of it's a mobile phone stand, I think, actually. So I'm just putting that on there for now, just to prove whether it's going to work or not. Now, I've been looking around for replacements of these washers and what else I could do. So if we go to the browse window, you see it does work. Now, these are mirror screws. Unfortunately, the clues in the name, they are screws. As you can see, they're not bolts. These are things that you're supposed to screw through a hole in the mirror to the wall, rule plug or something, and then screw these little dome caps on after. So it all sort of blends in with the mirror, and you can't really see where one starts and one ends. But screws are no good to me for this project. So, well, what else do I do? I mean, what else can I put on here? Well, I still like the idea of these domes. So I have looked at this. Now it says these are chromed carriage bolts. They don't look very chrome to me though. They look quite dull, so perhaps not my first choice. I then went to boltdepot.com. Unfortunately this is an American site, so I won't be ordering off there, but of course if you're in America you could do. They've got some chrome carriage bolts. They look quite nice. Let's zoom in. Oh, there we are. Now that would be quite good if I can get those in 4BA size in the UK. They could be quite good. I mean, that's exactly the sort of thing we want, isn't it? I mean, they do all sorts of various ones. They do flat ones as well with a hex key to put them in. That's pretty good as well. And they do all sorts. I mean, as I say, this is an American site, so I can't be ordering off that. I went to eBay. Now, eBay does some stainless steel ones. That also has got a hexadecimal key to put them in. Not ideal, but possibly better than what I've already got. But I do want to differentiate the top three compared to these two down here, on-off cameras. So I don't know, I'll enhance this over time and maybe I'll just post a quick update on one of my future videos to tell you how I got on. But functionally, using that Leonardo style micro, or Sparkfun Pro Micro, it's worked a treat. I've assigned all the keys in the code, so I'll put the code at the bottom of this video in the normal fashion. But frankly, it's not the code that's exciting, it's the fact we can actually make these touch keys talk to the Arduino, which then talks to my PC to let me do this sort of thing. Yeah, I mean that's it's pretty good, I think. Great. Okay, that's all it is. If you've got any comments or want any questions answered, let me know down below. And thanks for watching. See you in the next video. I hope you're finding these videos interesting and useful. You can leave comments down below and also click that little button that says subscribe. Okay, thanks for watching and see you in the next video.